Okay, yeah, we'll start at 7:05, and as we told the two speakers, the guests of today's event are will be presenting something for you by 7:30 or so. So if just make sure that you guys don't miss it.
Yo guys, I am audible.
Yeah, you're audible.
Yeah, so let's begin. Yeah, so hello everyone. This is I would like to welcome you all to the Aeromodelling Club of IIT Bombay. I am a second year student from the aerospace. I am currently member of the club. I will be conducting this orientation for you all today. So to familiarize you with all the different activity you can participate in during your stay here at IITB. So let's begin today's event with an address from our club secretary.
Yeah, hey everyone, hey guys. I hope the institute has been treating you well. And yeah, I'm Aman Malika. I'm the current Institute Aeromodelling Secretary. I'm in my third year studying mechanical engineering. I am crazy about drones, as many of you will be. And if you ever meet me in Gymkhana grounds, you can see me flying FA drones and all. Sure, I would like to have a chat with you once we are back in the offline semester. Okay, let's come to Aero Modeling Club. Aero Modeling Club is one of the premier technical clubs of the institute, and many people start their ventures into aerial robotics and other RC plane designs and all from here. And we hope to walk you the same path, and we hope that all of you are as excited as everybody else is. We have a great event coming up for you. Just wait and watch, and yeah, Godspeed. Bye.
So thanks, Aman. That was really inspiring. So in so let someone share the slide. So in today's presentation, we will start with aviation and aero modeling. Next, we will introduce you the world of drones through aerial robotics. After that, a live demonstration of club project from our campus. Then we will explore the aircraft design section. Later, our guest will present their skill in the air show. Finally, we make gliders. So let's move on the next segment. Over to you, Abhay.
Okay, yeah. I guess Abhay is having some technical difficulties. We'll sort it out as soon as possible. Yeah, why don't we start
Hello.
with Anirudh until that?
Yeah,
Abhay,
yeah,
can
I'm
you?
back.
Yeah,
I'm
we
back.
can hear you. Yeah, we can hear you.
Okay,
Okay,
cool.
sure.
Sorry for the trouble, guys. Hello, guys. I'm Abhay Kadpa. I'm a second year student studying in the chemical engineering. Also, I'm one of the conveners in Aeromodelling group. Now, I will give a short intro about what is Aeromodelling. Aeromodelling is an activity consisting of different activities like designing, fabricating, development of small air vehicles. Here we can learn different things. Either one of you would be interested in designing or fabricating an aircraft, or some of you just enjoy to fly it. Okay, so before you start designing your aircraft, you need to understand some basic concepts which are interesting, and also these things we will cover today. So things we learn in small air modeling are also applicable in complex aircrafts and rockets also. So this is the start to your journey in the aviation. Okay, the blogs. We have recently launched our websites along with a blog page. So reason behind publishing the blog page is to provide you information on aviation technology and its history and some stories. Later on, we will share some experiences of our seniors and professors working in this field. Also, we wanted to reduce your efforts in searching for the information and provide it to you all in a simple and interesting way. We have started publishing our blogs a month ago, and now we are publishing a new blog every week, and you will be notified about it through our Facebook and Instagram handles. So keep checking them. Any one of you have anything in writing blogs? Comment in the chat box, please. Okay, maybe some of you are interested, or maybe not. If yes, you can surely join us. If no, you should at least give it a try because it is a great opportunity for you to learn something, and I'm sure you will enjoy it. If you have any difficulty, doubt, or you want any help or guidance from us, we are here to help you out. If you are ready to provide a blog, we will publish it on our web page along with your name. Also, we'll post it on our Instagram and Facebook handles. So keep yourself motivated. Thank you. I would like to hand over to Anirudh.
Hi guys, I'm Anirudh, also known as Anna, a mechanical sophomore and a convener of the club. Now, one term you probably might have been introduced to is GD. And just like some of you, I had no damn clue what this thing meant in my fresh year. So what is a GD? Well, GD is a group discussion. And hard to break it to you, but it is exactly what it means. Discussion among a group of people. But there are some interesting things. Firstly, we have one or two, or if luck favors, more experts with us who have extensive knowledge of the field. They generally give a talk for about 30 to 45 minutes, and then all of us discuss various things about that particular field, right from noob questions to probably the most challenging ones. From various concepts to new innovative ideas, from skepticism on the technology to outright discussing something different altogether. So this year, we have proposed three GDs from our side. One is on application of UAVs in 5G. Small side note, UAV stands for Unmanned Aerial Vehicle. It includes aircraft like quadcopters, RC planes, unmanned gliders, etc. Just in case you didn't know. You might have heard about IoT, Internet of Things. A well-known example of it being the Tesla car. We too can explore different modes of technology of UAVs in the 5G era for complex purposes. Concepts like LDAL and HAPS have been discussed. Another is on autopilot. How do complex mathematical algorithms constantly monitor the flying conditions, the flying expectations, and decide various flight parameters almost instantaneously and keep us safe thousands of feet above the land? Also, we propose a GD on flight controls. Now, it's a no-brainer that controlling an aircraft isn't just a throttle and some other knickknacks. But do we realize the actual complexity of maneuvering an aircraft? We propose a GD to discuss and learn a lot about these complex devices and procedures that keep aircraft safe and in control. We have two more ideas. One is IC engines. You might have known that generally the aircrafts that we make are battery powered. Your batch could be the first one to learn about IC engines, internal combustion engines, and their utility and implementation. Also, you know what? Your batch will probably be the first batch to be able to collaborate with the Aeromodelling Club to design and implement IC engines during your stay in INSTI. Isn't that exciting? Another is rocketry. I can see some excitement. We are planning to build water rockets and have GDs about solid state rockets. Yeah, they are very risky things just in case you thought we would be building them too. Also, here's a video of our cool club seniors launching a rocket. This is a water rocket. Probably we will do some of these things too. Also, you know what? Your batch will be the first one to decide over some of the GD topics. Yes, you are freshers. Anything, any idea that pops up, tell us in the chat box. Anything. Also, if you have any other ideas and don't want to discuss here, feel free to post on the WhatsApp groups you're a part of with us or DM us on Instagram through our group or anyone in person. Probably the GD you discuss with us is probably the best one that we ever have. Now my teammates Harshil and Mete will continue from here.
Yeah, so hello guys, I'm Athar, second year undergrad from aerospace department, and yeah, I will be talking about drones. So let me share my screen first. I hope it's visible. Oh, sorry. Yeah, so like we guys asked you to fill a form. So in that we asked about your favorite flying vehicle, and many of you filled drones. Yeah, the drones are quite exciting, right? So drones are quickly developing and finding their way into a lot of varied applications since last few years. The major reason for that has been the rapid development in the technology concerning them. So these days, drones are much quicker, they fly longer, they can carry heavy loads. And you can see the drones are almost used in most of the departments. So it's a relatively new field, but it's quickly becoming a super exciting field to work in. Yeah, so the drones have find a variety of applications. So like they are used in agriculture industry, inspection, photography, quick response, search and rescue operations, and much more. So in this slide, you can see a few different types of drones. So they are like bicopters, tricopters, quadcopters, hexacopters, octocopters, and so on. The list is long. And don't worry, you will surely learn about them within the club. So in this slide, you can see this is the drone used for reconnaissance mission. So here we have all the sensor like cameras. One camera is it down, and this is the 3D radar. So this is usually used in a GPS denied environment. This is the aerial photo. This type of drones are used in film industry for photography, and yeah, you can see this is the drone used for delivery. So yeah, it has a lot of applications. So let's talk about making a drone autonomous. What does it need? So for making autonomous, so first of all, it needs is localization. What is localization? So the drone need to localize itself with respect to environment. What does that mean? It means it has to determine its current position with respect to its surrounding, right? The second thing is perception. What is perception? The perception means sensing its surrounding. So it has various sensors on board like radar, camera, and many others. Uh, so it has to like sense all these surrounding, and then it has to map the surrounding so as to see like where is the obstacle and where is the free space. Next thing is path planning. So like till now we have our surrounding, we have mapped it in terms of free space and obstacle. Now what we do, we set a start and goal position. Let's say a point A is start and a point B is goal. So it determines, so what path planning does, path planning determines a path compatible with drone dynamics, and to the part to be avoiding all the obstacles. So, and last thing is control. So so control people basically makes a controller, and the controller decide what thrust should be given to motors so as to move our code on our desired path. So yeah, let me show you this. So what happening here is, this is the code you can see, and yeah, it's the same code which I showed in last slide. It has all the onboard lidars and cameras on it. So what it does, it's moving in this house, which is GPS denied environment, and it's unknown. So it's, you can see here as the code moves in, it's the lidar basically, the lidar is, yeah, see here, the lidar is basically mapping all the walls and free space and giving its color accordingly. So in this way it maps the environment. This red line you can say is the path planning, the path planned by our path planning algorithm. So yeah, this is pretty much exciting, and you will sure, okay, so let me tell you, don't get overwhelmed by these things, cause you will surely get to know them once, over the years. So now we have planned to show you some live simulation demo. Yeah, okay. Another thing which I like to tell you, that we had planned a live simulation, but what is happening is there is a quite load on my system. So what we did, I just recorded a video. So it's a recorded, but I just recorded it will be same as live one. So let me share that. Yeah. I hope it's visible. Can someone confirm?
Yes,
Yeah,
it
okay.
is.
Cool. So yeah. So what's happening here is, we are using this platform called Gazebo. It's a simulator. So in that, yeah. So in this simulator, we have defined all, we have made this nice arena with frames in it, and this is, I will zoom on it. Yeah, this is the quadcopter Iris, and so see what happened here is, we in this whole simulation we are using a PX4 firmware. So what's a PX4 firmware, you'll get to know, but for now is something with the help of which we can control the drones, right? So you can see the propellers moving. So that's what PX4 firmware is for, and for communicating our Python script to that particular PX4, we are using Mavros communication system. So yeah, it might be again I'm saying don't get overwhelmed by it. Yeah, so now what I'm doing, I'm giving it a set point, which is 0, 0, 3.1, and you see it take off to that particular position. Yeah, and then I will make my code to pass through that frame. So for that I'm giving the set point 3, 0, 3.28. So yeah, code will move to that particular point. And see, although it's simulated, but it's quite similar to real environment. We can even simulate wind in this. Yeah. See, and again I'm giving the point 3, 0, okay, yeah, sorry, 5, 0, 3.28, and you can see the code passes through that frame. And let me tell an interesting thing, that I'm doing this by giving the coordinates, right? But in our another mission, what we did was, you can see there is a camera in front of quad. So what that camera does is, it we use some machine learning algorithm and image processing to recognize these frames. So what it does, it basically from the camera frame, it recognizes that particular frame, and then it finds the center of that frame, and then from we publish that center to our code. So it's fully autonomous. We have made this system, but I thought giving coordinate would seem more, yeah, interactive. So that's why we are doing. But yeah, we have also made this system fully autonomous. So for localization, we generally use SLAM systems. Again, what SLAM is simultaneous localization and mapping. Again, don't get overwhelmed. You will get to know all these things, and it's pretty interesting. And see, the club is here for that. So yeah, this is the Q ground control. It's a flight management system. I think, yeah, that's it from my side. I'll hand it over to Sabya. And if you have any doubts regarding it, and if you want to know like how we did this, anything, you just ping us. Okay, we are always there for you. Thank you, guys.
So, hello everyone. I am 𝐵𝐫𝐤𝐴𝐶, chemical engineering sophomore and one of the convener of the club. And now I am going to show you some of the RC planes and drones made by our club for various events and competitions. Before proceeding forward, let me introduce you to the concept of degree of freedom. So, an RC plane has 3 degrees of freedoms, that is pitch, roll, and yaw. This plane was, and there are 3 very basic parts of the plane, that is the rudder, ailerons, and elevator. These motions are controlled with the help of a servo motor, and this part is called fuselage of the plane. So this plane was made for the Boeing Aeromodelling competition organized in TechFest 2020. It has a wingspan of 120 cm into 21 cm and fuselage of length 75 cm. The main task of the competition was to take as many as golf balls as you can and as payload and take a flight with this plane. So we are capable of taking 8 golf balls at a time. Generally, the RC plane we made has 3 channels, 2 for ailerons and 1 for elevator. But this plane has total 5 channels, 2 additional, 1 for rudder and 1 for payload dropping mechanism. So moving on to the next plane. This plane was made for a Skyrus competition held annually at Manipal Institute of Technology. Last year, we bagged 3rd position, and this year we are the winners. So it has a wingspan of 120 cm into 25 cm and fuselage of length 90 cm. According to the problem statement of the competition, you need to take any payload of 450 grams, and there are poles on the ground around which you have to make an anti-clockwise rotation, and then drop the payload at desired location. Also, our plane has highest payload ratio of 0.5 among all the other competitors. Now handing over to Prathamesh for describing some other models. Thank you.
Hi everyone, I'm Prathamesh Nakate and I'm sophomore at Department of Mechanical Engineering and one of the team members at Aeromodelling Club. Now taking over from Sabhya, I'll show you guys some more models. Let me share my screen. Yeah, are my slides visible?
Yes.
Yeah, so this plane is FT Bloody Baron, and as unlike the planes which Subway explained, this plane was not made for any competition. It is just an hobby plane. And as you may have noticed, the design of this plane is quite unconventional with this, circular vertical stabilizer and this weird ailerons. And actually, this is also one of the reasons why this plane is not that stable, and therefore we use it to perform and practice all kinds of stunts. As far as the dimensions go, it is 60 centimeters in length and it has a span of 75 centimeters. So before showing some model of a quadcopter, I want to ask you guys a question. So as you might know, in quadcopters, one pair of the motors rotate in counterclockwise direction and the other pair rotates in anti-clockwise direction. So do you guys know the reason behind this? If yes, you can answer the poll which I have posted in the chat, and if no, you can still try. Okay, so now that I have asked this question, I'll show you one model drone built by a club. This name of this drone is Iris, and this is a photography drone, and therefore it has a dead cat configuration, which basically means that the frontal arms, these 2 arms, are wider apart than the back 2 arms, and this is done like that so that we can increase the field of view of the camera on the front. Actually, this is the main photography drone of the club, and it is used in all the major events for taking cool photos and videos. So till now we told you the different models that we have built, but you may wonder, where do we build these models? So actually there is a laboratory known as the Tinkerers Laboratory. It is the only student-owned laboratory of our institute, and it has all kinds of equipments like laser cutters, 3D printers. It also has some basic electronic components like Arduino servos. So that's where we build them. So now Sabhya will take over and show you some of the models which I just talked about.
So this is the bloody balloon about which Prathamesh is talking, and this is the iris drone, which is a photography drone, which he just described. So thank you. Handing over to Piyush.
Hello everyone. I am Piyush Purwal, Sophie from Aerospace Department and one of the member of Aeromodelling Club. Now let we discuss about some cool aircraft design parts and its functions. So yeah, this is a representation of standard fixed wing aircraft and its parts. It might seem very overwhelming as of now, but we will tackle them one by one. You are in the territory of Aeromodelling Club and nothing should make you overwhelmed about aircraft flying in aviation in general. So the airplane shown in the upper diagram is a turbine powered airliner that generates thrust that is forced to move forward through turbine engines. Smaller, lower speed airplane like RC planes, yes, that is coming up to use propellers on the nose of the aircraft instead of turbine engine for the propulsion system. Now the tail, it is the stabilizer part of an aircraft. So to control and maneuver the aircraft, smaller wings are located at the tail of the plane, and tail is usually has a fixed horizontal stabilizer and fixed vertical stabilizer. You might wonder that what role do this stabilizer perform? As in, why attach an extra component unless it's necessary, right? So well, as the name suggests, they stabilize the motion and the flight of the aircraft. So you will get to know more about stability in later orientation. So stabilizing action, it should be intuitive from the diagram that vertical stabilizer stabilize the yaw and horizontal stabilizer stabilize the pitch of the aircraft. So let's move to the control surfaces. So now all of you have seen the black part in wings and in horizontal stabilizer or in vertical stabilizer that are called the control surfaces of an aircraft. So first we will talk about the rudder. So rudder is this and it is the hinge part of vertical stabilizer. It is used to deflect the tail from left to right as view from the front of the fuselage, and it do yaw motion. Yeah, so now come to the elevator part. It is hinge part of horizontal stabilizer and it is used to deflect the tail up and down. Now let's come to the aileron. It is behind the wing and it is used to change the roll of an aircraft. You would be doing this in RC plane. Here is an exercise for you all. Next time, whenever you fly on an airplane, notice that wing control surfaces move during the takeoff and landing, and they are different in takeoff and landing. Additionally, you can try to observe that when aircraft turns, its control surfaces are different. Now let's come to the wing nomenclature. So all of you are designing your wing in glider event. So let's come to the wing nomenclature. So these are some technical definition regarding the wing geometry. So the front wing at the bottom is called leading edge. So this is called leading edge, and the back of the wing at the top is called trailing edge. And the distance between leading edge and trailing edge is called chord, that is this, and it is denoted by C, as you see like this. So this is your chord. Now the ends of the wing is called the distance between the ends of the wing is span, and it is denoted by the S. The shape of the wing when viewed from above looking down onto the wing is called planeform. And in this figure, the planeform is a rectangular. The chord length at every location along the span is the same, like this. Every this it is C. So can you think of another type of wing where it will not be the same? Like how about the triangular wing? So in triangular wing, chord is not the same. So, and one more thing, the wing area is not the total surface area of the wing. That is not the curved surface. The wing area we took is the projection area of the wing. Now let's come to the a very, very important aspect of any wing design is aspect ratio. Aspect ratio is measure how long and slender a wing is. The aspect ratio of wing is defined as span square upon area of the wing. And for this case, the aspect ratio is span upon chord. Now, this is the definition of wing. This is the definition of aspect ratio mathematically. But an obvious question is why it is so important in flight design. Well, a good aspect ratio for any aircraft provides sufficient lift and also reduces the drag. In general, high aspect ratio have long spans like high performance glider, and low aspect ratio are like fighter jets and all. Now let's come to the dihedral angle. So in this diagram, wing front view shows the left and right wing do not lie in the same plane but meet at an angle. And the angle that wing makes with the local horizontal line is called dihedral angle. Okay, so this is the all the nomenclature of the wing, and this is the isometric view of a normal RC plane, that is this. So now handing over to Vignesh.
Hi guys, can you hear me?
Yes.
Yeah.
Right. So, like Piyush was saying, fixed wing aircraft are the real bread and butter of our aero modeling club, right? We all have diverse interests, drones and UAVs and all that, but there's nothing that really unites us like just spending one Sunday afternoon making these planes and going over to the Gymkhana grounds to fly in the evening. And there's not much more excitement you can get than building and flying your own seaplane, right? And we've done a lot in the field of fixed wing aircraft. We've built a lot of unique, interesting aircraft like this one at the bottom you can see. It's a wing alone concept, and it's actually very hard to design and control. And we have a basic trainer for practice and proving our skills. Right? And we usually just work with foam and carbon fiber and a little bit of balsa, but we're slowly trying to explore more fields like internal combustion engines, new build materials, new build techniques, and you guys can be a very important part of that. And you guys are probably wondering, okay, all of this is really cool, but how am I going to do aero modeling from home? How am I going to do aero modeling in the online setting? Right? And to prove that, I want to just show you this plane that we designed. Skyrush 2020 is this national level aero modeling competition. And last year we came third. And this year this competition went online where we had to design and build an RC plane to drop COVID supplies. And this is what we came up with. We at the club had to use all our knowledge and experience to work in online. And we came and won first in the entire competition. There's also an RC flying part, which we did really well in. And this just goes to prove that you can always, no matter where you are, you can always learn about aero modeling. You can always practice aero modeling and explore aero modeling. Right? And what are the things that you can explore? Number one, I think aero modeling, because of the amount of hands-on experience it gives you a very holistic view of aircraft and drones and aviation. Right, so this picture is very interesting. If you just think about planes from one aspect, aerodynamics or structures or electrical, you will come up with some really crappy planes. But you need this hands-on experience to come with a whole holistic experience and do well, both inside the club and outside in drones and UAVs. And this is what the club can give you. Also, the club can show you some really interesting tools and skills. On your left is a CFD simulation that the club was running. CFD is usually a virtual wind tunnel where we can test our designs. And on your bottom right is a parametric modeling tool called OpenVSP. And this picture is very interesting because actually one of your freshies made this. And he was participating in a Tech Fest competition. And about one night before the competition, he came to the club and said, listen, I have no idea what to do. Please help me. And the club helped him and he got an honorable mention in the competition. Right, and this just goes to show that the club is a very open, welcoming place, and if you have any ideas, any help, the club is always there for you, right? And if you're bored of just planes, you can combine the world of drones and planes to make this a tail-sitter VTOL aircraft that one of our club seniors made and went on to fly later as well. and there's so much to explore in this field, right? And like I said, what's unique about the club is the hands-on part. You can learn the theory, you can buy the textbooks, you can do all of it. But unless you're working and building and flying these aircraft, you're not going to understand the intuition behind any of this. And that's very important. But apart from all this, my favorite part of the Aeromodelling Club is just that it gives you a peer group with common interests with whom you can have fun, work, learn, explore. And that's why the club is the perfect place for anyone who's interested in drones and fixed wing and anything that flies around. So thank you guys, and I hope to see you in club events and in the club later.
Yeah, can you guys hear me? Vignesh?
Yep.
Okay. I hope you guys are excited for the much awaited segment, which is you might have seen the videos that we shared with you about the IIT Bombay Air Show and all. So presenting to you, Taran Manaktala. Taran Manaktala started his flying when he was merely 4 years old. Currently, he is 17 years old and India's second best RC pilot. He has won numerous accolades for India, and he was placed number 2 at the Udaipur Nationals in 2017. In 2016, he was a part of the team that set the national record for the most number of aircrafts hovering in air at once. And hovering is very tough. Take it from me. And he will be performing 2 demos today, one of a 3D 100cc aircraft and one of a fast jet. On a side note, his medal is just more to USA, so technically that makes him the top-ranking pilot of India. He is on the number 1 position right now. We also have Saurabh Mistry, Mr. Saurabh Mistry. Mr. Saurabh Mistry has 16 years of aeromodeling experience. He also started his aeromodeling at a pretty young age. He's currently doing his PhD in aerospace department, IIT Bombay. His first interaction in IIT was in his second year during BE, where he was invited to judge the TechFest aeromodeling events. Yeah, we used to have those events before. Currently, this year we have a different set of events in TechFest. Currently, he voluntarily guides almost all college aeromodeling college teams in international competitions in Bombay and all over the nation as well, and has united them under the Saurabh Mistry Wings network to learn and grow as one body. Being India's top UAV test pilot, he has offered consultation and performed test flights for government organizations too. So, Mr. Saurabh Mistry and Taran, the screen is up to you.
Okay, so one sec, I'll just share the screen. One sec. All right, so Saurabh sir, you can explain the photograph.
So unfortunately, we'll be doing a simulator run today. Actually, we would have done it in person. But just to give you a brief of what we would have done in person, so these are 200cc aircrafts, and they both have IC engines. Both have a 2-stroke IC engine running on inline lubrication, and they use standard petrol. They have your spark plugs, ignition modules, everything. Apart from that, we don't have any flaps. So these aircrafts are meant to be extremely strong but light at the same time. So we get rid of all of the unwanted things, just the surfaces that allow us to perform. So yeah, Taran, you can start your demo. So the first demo will be of a virtual 100cc aircraft.
All right, so okay. So first off, I'm just going to take off right here. And now I will just do a roll right in front of you. And now I'm going to go up and I'll do a half cubanate with a slight variation so I can come out inverted. And now I'll do a few circuits of inverted flying.
So because he has a symmetrical airfoil, you guys will learn about it. It produces the same kind of lift inverted and normal. So that is why he can sustain flight inverted. So even
now
if you're not seeing it, sorry, go ahead.
Okay, so now I'm going to do a knife edge pass for you here. Okay, yeah, so I think I got disconnected, so I'm just going to continue on from where I stopped.
Yeah.
So here's a knife edge pass.
So he is relying on the side surface of the fuselage and the power of the engine to generate the lift.
And now I'm gonna do a snake.
Taran, give me a 30-second heads up before you enter 3D.
Okay, yeah, I'm gonna enter 3D in about 30 seconds.
Yeah, so these aircrafts have two main genres. One is pattern flying, which he did, and the other one is insane. It's called 3D flying, and he'll show you the beauty of it. So in 3D flying, your aircraft is flying mostly at stall speed. So apart from your wing generating lift, it's just not enough. So that is why you're quite reliant on your engine power also. Taran, are you coming in for a hover?
Yeah, I
so if you
already
guys can
exited.
hear me, okay, you exited. So it's a little slow from our side.
Yeah, I guess.
These are called rolling Harrier circuits.
Okay, yeah, so this is it for the prop, and now I'll be taking up a jet as well.
So while you load the jet, so we actually fly these, and I think Aman has shared the video. So Taran, you can start your flying. So
Okay.
they have an actual jet engine, and we run it on either diesel or ATF, depending on what is legally available. And they have your full retracts. The newer ones have electronic because of the weight penalties of pneumatic, but what I had was a pneumatic also. They have brake systems, they have full flaps to slow down and everything. So currently Taran is doing around a 210 mile per hour low pass. And at Ambi, which is near Lonavala, in reality he's clocked somewhere near 514 or so. Taran?
576.
576
That has been my
kilometers an
fastest.
hour. Yeah, kilometers an hour.
Yeah.
The extremely fast rolls are called rifle rolls. And the way he's maintaining altitude is he gives a blip of the rudder when the aircraft is at 90 degrees. And when he's inverted, he gives just a bit of down elevator. So his fingers are moving so fast that it keeps the aircraft in line. And if you want to keep the aircraft at the same altitude while rolling and also turn, then you have to just give a slight phase offset in your commands and it will begin turning. That's your inverted low pass. This aircraft is called the Rebel. Taran, this must be a 210, 220 Newton, or is this the
In
300?
this, in this there's a 220, I think. I'm not too sure.
Okay, so at sea level, the jet is rated to produce 220 Newtons. So that's 22 kilos of thrust. and the model will be around 15 kilos tops, I feel.
About.
Yeah.
Should I do the J10 as well or no? If we have time.
Yeah, you have another 3 minutes for 10
Okay,
minutes.
so I'll do a
ahead.
short thing for the J10.
Okay, so this is not mentioned, but he's going to do a 3D jet aircraft demo also. So he also has this, and I wish he could have shown it to you, but you can see it in his YouTube channel, the actual aircraft flying. So how do you do 3D with a jet? With a propeller, you have your prop wash even when your aircraft's not moving. So in this jet, you have thrust vectoring at the back. So when your aircraft is hovering, etc., it's a thrust vector that keeps the aircraft in control. So that is a Harrier. Yeah, that's your hover. So that is purely controlling on thrust vector. So this aircraft will not be as fast as the Rebel because this is a 3D machine. The other one was built to be a speed machine, so it will go much faster. So all of this we do in our line of sight. That is why we are legally allowed to fly it even yet. Taran, can you hold a hover in front for around 10-15 seconds so everyone can
Sure.
see?
Sure.
Yeah. This is a lag, so sometimes even I did not catch it.
Yeah.
Yeah, so this is where your thrust is equal to your weight, and thrust vector is where there's a nozzle behind your jet, and you can change the angle. So you can control your pitch and yaw.
Yes.
Okay, Taran, you can come in for landing.
Yeah, I am.
So just for your info, we conduct these air shows at Ambi Valley, sometimes once a year, sometimes once in 2 years. And I had taken a batch of students from IIT when it was conducted last. Actually, last to last, some in year 2018. So these facilities are open to IIT students. As and when air shows do occur, we can take you all over there to see. Okay, Taran, thank you.
All right. Thanks.
Yeah. Yeah, hi. So this is Saurabh here. So like Kaman told you, I'm doing my PhD and I won't take up too much of your time. I'll just tell you how useful I've found this. So I started this in my sixth standard, right? So the way I see aeromodeling, not just aeromodeling, but any club in IIT which builds your any technical club, I find it to be a bridge, and a bridge between what? So let's start with technicality and your books and practicality. So very often you hear seniors telling you, some will tell you, your marks don't matter, what you finally do practically matters. And then, your elders will tell you the reverse, that no, you have to get good marks because that's your final yardstick. That is what you're left with. And even I had that problem. I didn't know who to really listen to, and that you all will find yourselves in those shoes too. So what I found is neither can survive with the other, because what you learn in your books is what you will apply practically. And when you learn it in your books, they are just numbers. But when you actually see the effect, it leaves an impact in your head, and it develops your sixth sense, so you come up with a good design on your first shot itself. So that is one of the bridges. And the other bridges you will find you'll actually start valuing 5-6 years from now is you learn a lot of soft skills. And what are soft skills? You'll probably find them most useful when you start doing your first job. So soft skill is, how do you handle a team? How do you handle discrepancies? How do you handle people, and all of that. The other side is you'll be going for funding to various agencies, and you'll see how you're treated and how you can catch their eye in 30 seconds or how you lose it. And you learn all of these things, and it will come in handy one day when you start working. So keep an eye out for that. And remember to balance your studies and your aeromodeling or whatever club you want to join, because both are a very important aspect. And believe me, I've faced the brunt of both at times, and I've gone all crazy on my aeromodeling, and my studies have suffered. And I've learned my lesson. So don't go through that same process and don't make the mistakes I made. Yeah, I think that's all.
Thanks a lot, Mr. Saurabh and Taran. I'm pretty sure people would have learned a lot, and I'm like the lag was expected, so don't worry. We will share some recording with you if you would like to see that again. But yeah, I hope all of you enjoyed that. Thanks a lot, Saurabh.
I know there was a lag, but just share the YouTube channels, Taran's and mine.
Yeah.
Share it with them.
Yeah, I've already shared with them through mail. So I hope, guys, you can check that out too.
Yeah, you'll find his far more interesting than mine.
Yeah, yeah. Okay, sure.
Okay, thank you so much. Bye-bye.
Thanks a lot. Bye.
Bye.
Whoa, that was an awesome air show. Now it's time for the glider event. Are you ready? Okay, this is 𝐤𝐥𝐴 of second year. I'm gonna introduce you how to make a glider. Are my slides visible?
Yes, Jay. Yeah.
Okay. Before going into the main building stuff, let's take a few concepts with us. Let's start with stability, more specifically longitudinal static stability. I'll explain on that later. In our high school years, we did study this aspect of stability, positive, neutral, and negative. I'll repeat it in brief. So take this object. If you push it and it comes back to its original position, that's positive. If you push it and it just doesn't resist any change, that's neutral. And if you push it and it just goes to a more like the next stage actively, that's negative static stability. Yeah, just keep that in mind. Before we proceed with the more in depth of stability, let's take a bit of a look on airfoil. Yeah, so this is airfoil. They come in various kinds, and first terminology I need you to know is angle of attack. So when you see the angle between chord line and incoming wind, that's angle of attack. And yeah, so a short note on how airfoil produces lift. Oh, by the way, airfoil is the cross section of the wing. Just maybe I have forgotten to mention that. Yeah, and how airfoil generates lift. It kind of pushes the air downward, and by that Newton's third law, yeah, it generates lift. So someone asked in the chat, how does a symmetric airfoil produce lift? You see on this graph, this is by the way not a symmetric airfoil, but even if it would have been a symmetrical airfoil, it would have passed to origin, and with the increase in angle of attack, the lift would have increases. Yeah, so that's one thing you need to keep in mind. So now let's continue with what's aerodynamic center. Now, aerodynamic center is a point on airfoil where movement does not change with the angle of attack. That's pretty fascinating given that lift changes with angle of attack. Just again, a concept that will come again later. Oh, now I didn't mention longitudinal. Now you might ask, what's longitudinal? Now by longitudinal, we mention a plane, like we mean a plane which can be like defined by this longitudinal line and vertical line. So this plane can the plane can have three movements here, like three motions here. One, the two translatory and one rotatory. So we'll mostly focus on rotatory side because translatory is like thrust and up down. So why is stability important? Okay, I'll highlight a small video. If you don't keep in mind stability, what will happen? Yep. So do keep in mind stability. So with this motivation, let's dive into first question. What's this rotationary motion in the longitudinal plane? As you can see, if nose goes up and tail goes down, that's pitch. And positive pitch, this is what we call positive pitch. So just again keep that in mind. Even the moment direction is positive if it's applied in this way. Now we talked about stability. How does stability relate in this pitch kind of picture? Again, let's go back to the GIF. Yeah, this goes up. Now take a plane. Suppose you're traveling in a plane, and because of a sudden turbulence, it rocks up slightly. Okay, it rocks up slightly. Now, what will happen if it rocks up? So you do need a mechanism so that you can bring it back. Now that mechanism is what stability is all about. So to bring it back, you need a movement in the negative direction. And as the angle of attack increases, you need a higher movement in negative direction. So if you see the graph of movement versus alpha, Cm is just an embodiment of movement and AO is angle of attack. Nothing to worry about that. So yeah, if angle of attack increases, you need more movement in the negative direction. So that's a negative slope. You can see that negative slope is stable, positive slope is unstable, and the neutral will come more on that later. That's a very important aspect. So you might wonder what will happen if you travel in a plane with that positive slope thingy. Well, you better avoid those planes because this is what will happen. Yeah. So now we know a lot of stuff. Now let's figure out, let's use it in a practical aspect. You take a stick, you attach a wing to it, and see what happens. So yeah, here's our stick wing thing. As you can see, this man is standing at CG, and CG, by the way, is center of gravity or center of mass. I mean, in this small scale, it does not matter. Yeah, so a basic moment balance at CG will give you this equation. Just keep in mind, movement at CG is what we were measuring in the graph up. So just like fact. Yeah, and XAC and XAC is aerodynamic center, and XAC and XCG are measured from the start of the airfoil, the leading edge. So again, keep that in mind. Yeah, if it is this configuration, like CG is ahead of AC, so you can see this term is positive and MCG becomes negative. So yeah, that's what we wanted, right? I mean, MCG is negative, but let's see what happens at equilibrium point. At equilibrium, the moment at CG must be 0, right? So lift is equal to MAC by a positive term, and MAC, remember, is negative. So well, if MAC is negative, lift is negative. We can't have that, right? So okay, next let's move on to the next scenario. In this scenario, CG is behind XAC. Again, in this XAC minus XCG becomes negative. Oh, we immediately face a problem here. With the increase in angle of attack, lift increases and MCG also increases. So that's a positive slope thing. So that's like wrong. I mean, we just see why it was wrong. So again, we cannot go rely on this situation. Let's see finally what happens if AC is at CG. Well, then MCG is going to MAC. And as we told you, MAC does not change with angle of attack. So that means it's just constant. Now that's what the neutral line represented. But again, that's not stable, right? Okay, so stick in a stick and wing does not work. So what to do? I mean, the plane does fly, right? Well, yeah, it's tail. We forgot the tail. Maybe not this tail. the aeroplane tail. So what does a tail do? Now tail takes care of this problem by giving an extra movement that stabilizes the entire system. Now I'll explain that more with the neutral point in later slides. Okay, so we need a tail, but how big must be the tail? Now for that we have a ratio called tail volume ratio. Now this is a you can see here, that's tail volume ratio. By tail I mean horizontal stabilizer, just keep that in mind. So H is what we need. V is vertical stabilizer, that's yaw stabilizer. We'll come to that in yaw correction part. Yeah, LHT is a XAC minus XCG, that the thing which we discussed earlier. That's movement arm. I mean, just a terminology again. SHT is wing area and CW is chord length. SW is a wing area. Sorry, this is a horizontal stabilizer area. Okay, this is all formula and all. But what does this formula actually mean? Note, this is a non-dimensionalization of the power of the tail, or the effect of the tail on, the wing.
Jay, if I may interrupt you, just a minute.
Yeah,
to address some of the queries of people. Don't worry if you find this overwhelming. No issues with that, because when the actual build process will start, you have mentors. Mentors will guide you through each step of building and will clear your doubts accordingly there. Okay, so just hang on once we are done with this.
Okay, maybe I went a bit too fast. I'll slow down a bit. Yeah, so tail volume ratio is just actually a non-dimensionalized constant, nothing else. We defined something, we put a few terms together and came up with that. But why this, why tail, why specifically these terms and all those things? So it's basically a non-dimensionalization of the effect of the tail on the plane. Now, why do we if you explore this field a bit further, you'll see that there's a lot of non-dimensionalization going on. Why do we do that thing? Now, you remember similarity you did in high school? Yeah, like that. If you study the properties of a small triangle and it's similar to a big triangle, they'll just propitiate, right? So the basic idea is the same idea that follows here. So what we do is we study the property of a small prototype, we build it, we do wind tunnel testing there, and then by that we actually take find the properties of a big real size plane using these constants. So that's just the intuition. Yeah, so that winds up the stability part. Let's move that's a bit more on the left. That's the neutral point and static margin. Let's move to both of them. What's neutral point? In one slide I did mention this case. Well, it's neutral, right? I mean, there's a change. It doesn't quite come back to its original state. So what will happen when that, in this case, this GIF illustrates it. If there's a turbulence, it just goes to some point and sticks there. Yeah. Why is this neutral point important? Yeah, one thing which you need to keep in mind is the neutral point of a wing is the aerodynamic center, right? We just discussed that, because CG is equal to AC, then this happens. What about the neutral point of tail? Tail only, right? Not with tail. So that's the aerodynamic center of the tail. Now, what will be the neutral point of wing plus tail? Well, that will be the weighted average of neutral point of wing plus the neutral point of tail. Okay, so what's the use of this neutral point? Now, you remember the part where I told that if CG is ahead of AC, the slope is negative, but we get a negative, lift. So it's stable, yeah, but with a negative lift. So the CG must be ahead of neutral point for stability. Okay, that's one point. The last thing which I need to mention here is the static margin. Now, more the difference between CG and AC, or neutral point, the more is the stability. Now, the distance between CG and neutral point is highlighted by static margin. Just a term that will come in handy. What if you have CG behind the neutral point? Now, I've taken a video of what will happen if CG is behind the neutral point. So don't try that, because if this happens, your plane will just, with slight turbulence, would just flip kind of. So by the way, that GIF I showed you, that's a tail heavy aircraft. You need to avoid that in trimming process. Now, what will happen if CG, well, I told you that we are safe, right? If we are ahead of a neutral point, CG is ahead of neutral point, we are safe. So we can have CG anywhere ahead of neutral point, right? Well, no. because you see, if CG is too ahead, we at equilibrium, we'll have negative angle of attack, and the plane will simply drop, as you can see. Remember, this is a nose-heavy plane, just so you know. Yeah, those two slides I show you, just keep that in mind, because in trimming process while making a glider, those will come in handy. Okay, so let's build a glider. Now, building glider is very easy. It's just like making a soup. Okay, so what you do first while making a soup? You open the recipe book, right? So for glider, we need to come up with the measurements. So how to fix the measurements? Now, first you will start with weight. Okay, it's an estimate of weight. Okay, an upper cap of the weight. You do not actually measure the weight. I mean, because you cannot, most of you. So you just try and estimate the upper cap and work with that. And we take the wing loading values. Now, what's wing loading values? Like intuitively, it's just how much lift can one, per unit area of the wing can provide. So these are the typical values. These are again measured experimentally. So yeah, for glider is 31, and we'll use 31 for our calculations. And with that, we'll obtain the wing area. Nice. Now we have the wing area. Now what to do with the wing area? Now remember aspect ratio? Yeah, that will come in handy here. That will the aspect ratio will give us the span and the chord. Now with span and the chord of the wing, we have all the dimensions required for the wing. Okay, now let's move on to the next part. By the way, aspect ratio which you need to take is between 6 to 8. Again, that's an experimental data. Like 7, 7.5 is also okay, like 6 to 8. It may increase a bit, but do not go below 6. It will create problems. Now we have the wing. So now what? So now let's start with the stabilizers. For stabilizers, we'll use a tail volume ratio, which I mentioned in some slides before. In the formula, there was this movement arm xCG minus xAC. Now that's done experimentally, and actually it involves something. It's a bit involved. So we did that for you, and it comes out to be 11 centimeter. So now if you just plug in the values of your like rest of the values are just given to you. So if you plug in the values, it's approximately 15 to 30%. That's the area ratio of wing and horizontal stabilizer. Now you take the same measurements for vertical stabilizer, and that ratio comes out to be 8 to 16%. Just like your main thing is just to take make sure the ratios are satisfied. You do not need to come up with the entire calculation. Okay, so now we have all measurements. Let's start making elements of a thing like airfoils, wing, and all those things. So first, now take a cardboard. Now cut out the outer layer of the cardboard. You do not need the entire cardboard, it's too thick and too heavy. And from that, and the measurements given, make this cutout. Now, if you have a span as like 6 centimeter, the width of this cutout must be 12.5 or something. You need to leave a bit of a margin for the folding. And also cut the airfoils. The number is depending on the number of ribs you have. Now, ribs again, I'll highlight in the next slide. Just keep that in mind. Now time to make the wings. Like we take the stuff we made in the last slide and barbecue the kind of stick to the airfoils to the stick kind of. And these are the ribs. The bunch of airfoils visible in the image. These are the ribs, and the central broom. That's the broomstick, by the way. The central broomstick is the spar. Now you place that in this cutout we made and fold. The entire process is done step by step in a YouTube video, which we will be providing you. So don't worry if you don't get it. Just keep in mind the overall picture. Don't get worried about the details. Okay, now let's make the stabilizers. Now stabilizers, you just need to cut cardboard pieces in the right dimensions. Do not stick them now. This is just for illustration purpose. In this step, it's just cutting, nothing much. Okay, now the final step is not the final step, by the way. This is the final step of the build, not trim. So this is the time to assemble stuff. So now we have broom bristles, the thing which we mentioned to you in inventory, and the last few slides, and you made, and you combine that to make this. So what you need to do is take 2 broomsticks or broom bristles, whatever, and tape the head. Tape it in such a way so that maximum area, like there's a maximum contact between them. Now pass your wing through the broom bristles and make sure that you press the broom bristles such a way that there's a strong grip between the wing and the broom bristles. By the way, that broom bristle will make the fuselage. Okay, just remember that. Yeah, so it will look something like this. And finally, you tape the wing with the fuselage. After that, you add the stabilizers. Now, this adding the stabilizers is similar. You just need to tape like whatever adhesive you are using. You just tape them and add adhesives, and yeah. Finally, the plane would look like this minus the rubber band. Rubber band comes into the trimming part. Well, we are almost ready, but now the last and the most important part, the trimming. I mentioned trimming in a lot of slides in the stability also. It's the entire reason we go into the stability business. Now, while you made this thing, you now need to make sure that all the movements are balanced. Now, to balance the movements, you need to just ensure about 2 movements. The yaw is automatically balanced by the vertical stabilizer, that triangle shape protruding out here. Yeah. So roll and pitch needs to be stabilized here. Now roll will be stabilized easily by adding a dihedral if you can. Okay, it's not recommended. If you can add a dihedral, dihedral is again the angle between like this, between the wings. But if you can't add a dihedral, add an aileron. Just cut at 2 edges and intuitively set it in such a way that it does not roll. Yeah, apart from that, now you need to make sure the pitch is balanced. Now pitch stability is what we talked about in the stability section. Okay, you need to make sure that it is not tail heavy or wing heavy. Sorry, nose heavy. So what you need to do is you need to make sure that the CG is at C/4. Now, why C/4 by the way? You remember the neutral point of the wing is at C/4. But when neutral point of the wing and tail are added, it's an average. So C/4 comes in the safe region. Okay, so just keep that in mind. So you need to make sure that the CG is around C/4 region. How do you check that? Just balance it at that point. If it's balancing well, okay, like your plane is good to go. Now throw your plane a bit and see check if it's going nose down, if it's going tail down, tail heavy or something, and modify accordingly. Finally, you need to throw the wing plane. Okay, that's it from my side. Any questions you have will be addressed by your mentors. Just like go to your allotted channel and ask them the questions. If they are still not cleared, you can like message them in the general. We'll clear them for you. Thank you.
Yeah, okay. I think Jay is done. So just before we move on with anything else, I want to assure you that whatever the entire build process is and whatever the instructions are, that will be made clear to you. That's why we have the mentors. So don't worry, just be calm for now. Also, you guys have your dinner. So we will have a slight 20-minute break. You guys can have your dinner, and we will come back again. All the you guys have been added to the specific groups. You can see a group against your the main channel, general channel, and from those groups you can directly join in, and your mentors will be waiting to guide you to the entire build process. So yeah. See you again in 20 minutes. So all of us, most of us will be here only. You can join again after having your dinner. Also, those who are not planning to have their dinner right now, don't worry, you can join the channels. We'll start the meet soon, and we'll give you instructions accordingly.